All right, so first of all, quick review. You should be able at this point to do the anes, the enes, and the ines. Ane being what? All single bonds, no doubles at all. All right, ene being double, and ine being triple. All right, just a real quick thing. This would mean that this has one pi bond and one sigma bond, right? And this has one sigma and two pi bonds in that particular bond. Good? All right. Now, so far, all we've talked about is carbons and hydrogens. It gets much more interesting when you add in oxygen. All right? There are 6 different ways, basically, that you can have oxygen tied in. All right? The simplest, and they chunk into 3 groups. The first one is all single bonds. All right? There's 2 ways you can do it. You could have a carbon with an oxygen with a hydrogen. And then what we're going to use is we're going to use R being the other stuff. All right? And so you would have something like this. All right? This is called an alcohol. All right? Alcohols. Simplest alcohol is this stuff with just 1 carbon, thus. All right? This is called methanol. You end the name with an OL. All right? So this would be methanol. Now, what's methanol? Methanol is wood alcohol. Do not drink this. It will actually make you go blind. Okay?
That's so weird. Like drinking it makes you go blind.
Right, because methanol actually goes to the optic nerve and destroys the optic nerve. And then if you drink more of it, you end up dead. You end up dead.
Why? So why do they like why does it target the optic nerve?
I don't know. I'll have to do some research. Let me look into that and I'll see if I can give you a better answer. All right. Now, of course, with 2 carbons, right? That's F, ane, no double bonds. F, ane, ol. This is the stuff you drink to get drunk. All right. Drink enough of it, it'll make you dead because it's a depressant. Drunk, like as in you get drink.
Like tipsy.
This is the stuff you actually drink. This is what's in all alcoholic beverages.
Like the proof.
All right. Correct. And the proof is simply double the
alcohol content.
The percentage. Now, why they decided to do it that way?
That's so weird to me. Like,
Very
just like
strange.
pick one. Like, you don't need both of it. Say the same thing.
Correct. All right. So these are the alcohols. Now, the other way to hook it in single goes like this, where we have some R group. We'll use R prime just so it's distinguished. All right. The O, and then a different R group. Okay. This is not an alcohol anymore. Alcohol has to have the OH on the end. And notice this is not acidic or this is not basic because these are all strong covalent bonds, so it doesn't split up. All right, this is called an ether.
Ethernet.
No, not the same thing. All right, so ethers, the simplest ether is simply an ether. You ever heard of ether? What does ether do? What's that? It's an anesthetic. All right, it'll knock you unconscious. All right? So they used to administer ether as a way to knock somebody out before a surgery. You had to be very careful in the dosage, but it was a very effective way to knock somebody out. All right? This would be basically the simplest one would simply be 2 carbons. All right? And stupid way to remember it is something like that. Remember, it would be bent because of the 2 unbonded pairs. So it's kind of like the ether bunny. Sorry. Thank you. Thank you very much. All right.
I made my day worse.
What's that?
That just made my day worse. You should take that course.
Wow, it's good to have friends. All right. Damn shame I don't. All right. So next one is where we could have a double bond. All right. Double bond. So simplest way to do a double bond would be some other R group. Again, I'm just going to use just R, even though they're different.
R
Rs.
groups.
Okay, R.
Why?
Why?
Bio.
Yeah, isn't it wonderful?
Not
It's just
really.
the other stuff. That's all it means is the
Yeah.
other crap.
Yeah.
All right? And so what we could have
The
is
rest of
something
it.
like this. All right? Where there's a double bonded O on the end. This is called an aldehyde. If I can spell. Aldehyde.
Formaldehyde.
Yeah, like formaldehyde, which they figured out was a carcinogen, so they stopped using it. But when I was a kid here at
Using it for
TJ,
what?
we had a bunch of samples of all
Isn't there
sorts of things.
formaldehyde in like furniture?
Yeah, you do get small amounts of formaldehyde coming off in a variety of different things, all right? So, yeah, that's why you really, if you buy, say, a mattress, you should probably leave it in a vented room for a while to let that clear out before you start to use it.
They still use formaldehyde.
There's a lot of things where they've got little bits of compounds that get in there unintentionally in the synthesis process. Because when you're synthesizing some of these polyesters and things, it gives you, other compounds and they don't completely clear it out. That's why we hold the whole limiting reactant thing's a big deal. Because you wanna clear out the, all but the product that you want, all right? Now, next one, of some interest to some of you, because you use it occasionally, these are ketones. All right, and the simplest one you may have heard of is acetone. Acetone is a wonderful solvent. All right, where is the most common usage of acetone? Nail polish remover, exactly. That's why you go by some of those places and it absolutely reeks because they're using massive quantities of acetone. The trick with acetone, and I'll show you this, is did I already do the fire with the whoosh bottle?
Yeah.
Okay, did I show you acetone and how big a? Yeah. Okay, the trick with acetone is you have to be ridiculously careful because it is very easily vaporized. All right, you don't want to do acetone in a small room and then light a match. No, I'm serious. I mean, I've seen situations, look it up, if there were actually acetone fires where somebody was doing their nails, left the bottle open or spilled some, and they were like smoking a cigarette or whatever, fireball.
Fireball.
No, not the alcohol, chill out.
Fireball.
We were recording this for posterity.
That's a song.
I know, sort of. All right.
I have a question. Mr. Renee, I have a question.
Yes.
So if you just leave it open, but like none of it's open, it can't still light, can it?
We could try it.
Like if you just let it kind of chill for a little bit. it can
Okay,
still-
so come on back. So let's actually, we'll do that here in a minute. I'll go get some acetone and we'll experiment. We'll play around with it a little bit. All right? Because the trick is, when I did it, excuse please. When I did it, I dumped it on a table so it had lots of room to evaporate. I'm curious if it's in a beaker, because again, you'll decrease the surface area. If it's in a beaker, then the only certain place it can evaporate is here at the surface. All right, if it's a spill, obviously the entire distance over which it's spilled can evaporate, so you get much more vaporization. All right, so I'd be curious how dangerous with how much, et cetera, et cetera. All right, you have to be really careful with some paint thinners will have that acetone in it. And you have to be careful because if you're using that to clean brushes and stuff and working in a small space, not so good. All right, okay, so that's doubles. Now, then the last two are double and single. All right, double and single. And this, if you don't know what this is, you have not paid attention for most of the school year. What is that? Double bonded O with an O with an H on the end.
A carboxyl
Good. Carboxylic
acid.
acid. Thank you. All right, those are acids. Because what you've got is you've got this really strong OO here, which gives you a very strong dipole negative there, which means the H is very, very, very strongly dipole positive and can be pulled off. All right, acid. All right, and the last one of the oxygens is double bonded O with an O in the middle. Okay, this is called an ester. What's it?
Polyester.
Like as in polyester. Okay, one of the things you'll look at in the lab today is what's called an esterification process. Polyester, you guys know that polyester was a total mistake. It was just a happenstance. All right, the guy was mixing together. Let me see if I make sure I get it right. An alcohol and an acid, and what happened was he had two distinct layers. This was over at DuPont in Delaware. He had two distinct layers, and he had a stirring rod in there and started working with it, stirred it, pulled the stirring rod out, and it looked like this long line of, well, it looked like a long line of snot, all right? But it looked like a long fibrous mass, and he just kept pulling, and it just kept forming,
Oh,
all right? Yeah, and he said, shoot, this could be, you know, this obviously could be useful, and then they started playing with it and realized they could make it into thread, all right?
Wait, don't you have to like put two?
What you do is you draw long string threads, and then you weave them into, like, you ever seen a weaved rope?
Yeah.
It's the same thing what you do with thread. All right? Okay, the other one, last one, under here, called, when you deal with nitrogen. All right, you can have an NH2 group hooked to the end, and that's called an amine. All right, so what's an amino acid look like?
Probably that with the weight.
Okay? Anybody, AP Bio, maybe even regular bio. All right, what is an amino acid?
Protein stuff.
It is the isomers of proteins.
Okay, but what does it look like?
Was I right? Was I right?
What does it look like?
Oh, they have R groups. Put the R there. There you go.
All right,
Know that.
so it's an amine with an acid. And the rationale is that the amine and the acid, you can connect, take off one of these H's and this H and the O, and you can connect one amino acid to another amino acid, and you make a long string, a long continuous chain. With polyesters, you take an alcohol and an acid, and you can have alcohols at both ends, acid at both ends, and they can make a continuous chain. All right, so you'll see that. All right, if you could stop that.